to know a lot of things in the domain of asset management. I won't call, asset management to be centric to a certain application like power grids. Like asset management is more generic, you guys already know, right? And we'll be speaking about it. But then again, when we do talk about power grids in per se, um, I kind of, got some idea in my past to, give this entire application a certain flavor. Um, as Sanket was mentioning, I currently work with R&D department. I'm a manager in pre-sales and marketing for Scope, and I am a customer success manager and a product owner for Oxygrid. So basically, what we do is that we gather the instances from the customers, get their feedbacks, give them, certain set of use cases, see what are their reactions like reinforcement learning, and we bring this entire story into the CAP platform. Again, before starting it, the basic idea about what Oxygrid is. Oxygrid is a digital IoT platform for Scope. And Scope, as you guys already know, or if there are people who do not know about it, we are the leading manufacturers in testing and measurement instruments. Okay, so having spoke about it, here a little bit particular details. We are a company with 35 years of experience in high-tech power sector, where we do deliver TNM, which are the testing and the measurement instruments. We are the manufacturers, and we do, installation as well as the protection for these kind of electrical circuits. Apart from that, if in terms of business success story, we have deployed automation projects all over India. And having talked about international markets, we are the people who have started understanding that the digital IoT solution is again a very good business case, which has to be completely perceived in UK. So we have an Oxygrid headquarters, which is based out of UK, but then the innovation actually gets propagated all across the globe. All right, so let's talk about the subject. So when I say asset management talks out to be a very generic term, but happens to have a very specific meaning. So as the word says, it speaks about any particular component that you have in your application. Like let's say it could be renewables, or it could be high voltage transmission lines, or it could be wind turbines, or it could be n number of applications. I mean, wind turbine technically do fall under renewables only. But then having spoken about it, to generically speak about what asset management means, asset management actually speaks about understanding all the components that are there in your portfolio, how they're performing, what are the possibilities of failure, what are the cases where you might find a risk of replacing them. Now, having spoken about a one-liner definition of what exactly asset management means, let me speak to you about a little bit of an executive summary of what the entire business case holds of an asset management kind of application scenario. So there are a few statistics which possibly I hinder upon, where it has been believed that if we take base year to be 2021, the overall market size till 2030 is supposed to grow at a whooping 7.3 billion US dollars. So if at all if I have to speak about what exactly is the overall cumulative annual growth rate, or the CAGR, the overall business case bounds to be around, with a CAGR of around 9.9%. So it's just something which has a very stagnant growth, like a linear one. But then again, the possibilities in terms of finances and investments and reduction in the overall operation and maintenance cost is humongous. So you would be in a certain situation where you are investing something which is making sense, but then again the entire value would be reaped out when your O&M cost drastically go down. And that's what we have seen over the days, like all the business cases that do have evolved in the recent past or in the future, in the present, they have been all the OPEX models, right? So since the entire system is now started moving from CAPEX to OPEX, It has so happened that, the fundamentals of prescriptive analytics or assessment in terms of understanding how the components are doing to give you a deeper insight of how exactly your components can be optimized, or how can you optimize your resources so as the overall OpEx goes down. So that's been a biggest challenge in the recent past and the present, which can be technically, solved, I would say, using the ideas from the asset management and prescriptive analytics. We are going to talk about it, but this actually happens to be the basic fundamental of what the business case goes around. Having spoken about it, majority of the drivers come from the public and the private utility sector, which is from the side of the energy or the power sector. Okay, I'll be speaking more from the power systems application. Again, DISCOM and the utilities are the major people, whom this entire presentation has been targeted for. Apart from that, what are the restraints? Okay, the survey says that some of the technical restraints that do happen to such kind of a business case are related to lack of skill force or high cost of implementation, lack of technical expertise. Like, it might so happen that, you would be looking into a SCADA, but you don't know how exactly to drive it, right? There are so many notifications that actually come out of the portfolio that you have actually built up. Like, if you have a digital IoT solution, or you have a SCADA service, which gives you a portfolio of devices, like, you're managing your assets in certain tabular format. But then when it starts giving you controlling actions or certain sets of prescriptive notifications, then many a times it so happens that none of them are actually aware of what to do next. What are the different components that actually go into? They are definitely related to hardware and software, because the need of implementing an IoT, and IoT allows you to enable the entire assets which are present in your application, and a software is something that actually allows you to drive all these IoT sensors remotely, right? Sorry. Okay, apart from that, what are the applications which we are looking into? You have substations, transformers, inverters, renewables, generation, transmission, and distribution. I have not tried being specific to a particular classification as such, because these are very fancy names which are known in the industry, right? So I've tried putting them down per se of their relevance in a power grid. Okay. So for instance, inverters could be omnipresent, like in different sets of scenarios, right? Wherever you are generating from DC and you're giving it to an AC power system is the place where you want to know how an inverter is doing. Similarly, transformers could be on the generation side or on the transmission side. We are all aware of that. But then the idea over here is the business case for an asset management is, is kind of looking around these kinds of assets, and I try putting down in terms of their popularity. So these are just the growing statistics from my previous slide. So basically, as you can see, it's from 2021, if I take it as the base year, with a linear growth of around 9.9%, I'm expecting that the overall raise in the market share could be around 7.34 billion US dollars. Now this is just about the fact that where the entire study was conducted or the survey was conducted. But then if I have to speak about like what are the geographies where the idea of asset management has either have incepted or has grown or has the popularity of capturing a market, because India happens to be a developing, or this Indian subcontinent for that matter happens to be a growing market, right? I mean, we are all aware of it. So in that case, what happens in terms of a geography and how the idea of asset management would possibly propagate, if I have to write it down, I would say it would look something like this. So taking 2021 as a base year, the Americas are, falling into a 38% of the pie. The Asia Pacific fall into the 29% of the share, and the Europe comes in at 23%. Apart from that, 10% happens to be the rest of the world. So if you can see, the idea of having it seen from a different perspective of a developed country and developing country, this entire pie has the capacity to actually move more towards or incline more towards the Asia Pacific region because of the fact of higher outages and looking into a more complex power system. When you look into more complex power system, thing like an asset management actually helps you out. Well, why? It's very intuitive because of the very fact that in a complex power system, you need to know each and every component out there and how it is performing. Any single nodal failure is a direct, impact on the outage of a power system. Yeah, so that's something that is kind of killer. Okay, having spoke about the market from the executive end, let's drill down to another peel of layer. What is the need of an asset management kind of a solution, right? As we spoke about that in a complex power system, you need to know that how exactly the propagation of entire energy happens in terms of energy loss, in terms of how the entire energy is being channelized towards the entire power system, right from the generating end to the channelizing end and to the point when the distribution happens to a consumer. Do you need to know the fact that during this course of energy flow, there are energy thefts, there are places where there would be higher losses, there should be malfunctioning, there should be places where there are failures, and there are islanding and whatnot. In such kind of scenarios, one of the things that I was mentioning before is to know your asset, like we call it as like characterization of a plant, right? Similarly, you need to characterize an asset. When I say you need to characterize an asset, what do I mean by saying that is, do you know the pulse of your asset? Like, for instance, we all know that resistance can be characterized by a linear equation of the form voltage by current, right? The voltage applied and the current flowing through it normally gives you what is the resistance. This happens to be a model or a formula which tells you that how the resistor as an asset is going to perform given certain set of electrical conditions, right? Think about it that I'm just speaking of from a very micro level. If I go to a very high level power grid where you will be having power transformers, you'll be having circuit breakers, you'll be having electrical relays or inverters or photovoltaic panels and all those kind of applications coming into picture. I won't say applications, the components coming into picture. Do you have the capability of understanding them to its pulse? Why? Because asset management needs to have a reference or a datum. When I say a datum, it has to be a model which tells you what should have been its characteristics or what should have been its normal response to a certain stimuli compared to what is actually happening on the field. Then when you do a referencing, you'll find out that there are some deviations, and then that deviation happens to be the source of identifying what has been the problem with the asset. That's how you do reverse engineering and find out where the fault is occurring, right? So the propagation would necessarily happen if at all you know what are the terminologies which are related to it. And this entire story, if you could see when we see it from the past, it kind of gets propagated from descriptive formulation. And if I just have to chart it out, that how the CAGR have progressed from the point where we thought of looking into the data and see where the description of the fault lies. Okay. Now, again, let me just keep everything on track. Asset management requires characterization. Characterization requires meaningful analytics. And the analytics started from descriptive. So I'm just speaking about the fact that where the entire story began. And why is it necessary? Because right now we are just trying to put down the business case of an asset management kind of a scenario, right? So when we did the idea of descriptive analytics, okay, fine, there is a deviation, then that deviation means something. You just find out and you said that, okay, this was the problem and this needs to be fixed. When you find that there is a problem, that's description. When you diagnose what is the problem using manual tools like maybe Microsoft Excel or a Power BI or something of that form, you call it as a diagnostic solution. This happens to have an overall business growth of around 9.5%, as you can see on the screen. Now, having spoken about a growth of 9.5%, it's still not appreciative for a utility who invests millions of US dollars or millions of Indian rupees to get a particular power system flowing. Imagine big utilities who are actually investing good amount of money, or if there are independent power producers who have invested good amount of money into a certain power grid or generation project, when it is being delivered to a particular consumer and there are power outages happening into picture. That's the point when the entire idea of having a system analyst actually comes into existence. The moment you identify the fault, the next is to fix it. But then this is more of a post activity, right? Like a posteriori, right? If I tell you that there's something called as an a priority activity, like a predictive solution, then definitely it's as good as saying that that today is going to rain, so you are definitely going to carry your umbrella, right? In that similar sense of or similarizing something like that, I would say then the predictive models came into existence, which did talk about the fact that, okay, I have a characterization model, which will tell you that given a certain set of weather conditions or specifications of a given electrical component, this will be its corresponding generation, or this will be its corresponding output. Now, the next is to do a benchmark. You said that it is going to produce so many units vis-a-vis on the site or on the field it is generating, let's say some units. Then you do a deviation, automate it, and you try to find out that where exactly the deviation is lying, which was not the case like 20 years or back when we just kind of got exposed to something called as diagnostic solutions. Having this into picture actually improves your CAGR by almost 10 to 11%. So you can see that there is a growth of 9.5% to 22.1% when you actually move towards a predictive solution. The next big idea or the next big thing is nothing but the prescriptive, where having said that there is a deviation and that, okay, the deviation is because of a transformer, or you have an intermittent fault, or you have an inverter, which is actually having its MPPT issues. What do? The next thing that you do is to define a log, which will tell you the set of actions that need to be performed by an O&M engineer on site in order to make sure that there are no outages and the failures can be reduced. Because at the end, it's all a techno-commercial bucket, right? So when you do that, it kind of allows an O&M engineer to optimize the resources. And at the end, when you see it from the overall return of investment perspective on an OPEX model, you see that the OPEX is actually reduced, which in turn allows a business to grow faster. So if you can see, predictive to prescriptive is more kind of a scenario where you need not have much of a brain. Everything else would be done by a computer. You just give computer the brain, let him think that whenever there is a fault detected towards a transformer, or if there is an issue with the heat sink of an inverter, in that case, what should be the set of items or a toolkit which a O&M engineer should carry so that it can actually perform an operation or a maintenance activity in order to make sure that the overall OPEX can be reduced. This is kind of a solution which actually improves your CAGR more by 10%. and it actually grows from 22.1% to 31.7%. Now, if you could see, let's say if you have a portfolio, like you have an application on your mobile phone, on your iOS or Android, and every single day before actually going onto the site, you find out that, okay, your transformer or a circuit breaker is having a health index of 3 on 5. Okay, so there are 2 points that have been that are actually removed out of the solution, or maybe your circuit breaker is not performing to its to its potential, and you find out that that 2 out of 5 is going somewhere which can be actually fixed by the prescriptive notes given by a model. All you need to do is that you just need to train an engineer or a commerce guy, anyone who actually understand how the operation works, and he can just take our TLM instruments to that particular field component, perform those tests, and find out if there are any issues or not. He can fix it. The moment he fixes it, the overall power system has a ready to go solution. So these are all the activities that get bucketed when we talk about asset management portfolios, bringing down layers or hierarchies of different kind of assets, which do find a significant impact in a power system. Okay. So we are going to talk, we are going to talk more about, I'm so sorry. We're going to talk more about the business case. Well, why? Because first of all, we need to understand that how asset management kind of becomes a valuable proposition to majority of the discounts out there. And if there are any data scientists or any of the analysts who are watching this particular presentation, you guys know what are the problems to attack when you start seeing and looking into the data which has been provided to you. So think about it like this way. If I put an X and a Y axis, as I'm showing it on the screen, where on the x-axis, I say that everything on the left are related to everything that is easy to be reported. On the right-hand side, I say that some of the things which are hard to be reported. Similarly, on the y-axis, I say the high impact of all those KPIs, for instance, of a transformer, if I talk about OTI and WTI. Okay, if I say that there are no, let's say, sensors available for an OTI, but WTI is available, like you have already installed an RTT into place. In that case, OTI measurement is something which comes on the hard to report segment. But then if I have to talk about the impact on the organizational value, OTI and WTI, as we all know, they have a higher impact on the overall organizational terms, right? Similarly, if I do talk about the divisional value, which is the negative y-axis that I'm showing on the screen over here, you see that OTI and WTI would definitely fall on the organizational value side. If I have to speak about something like a power factor, or let's say disturbances in voltages or harmonic distortions, those kind of things would possibly come under the high impact on divisional value. If I set down these KPIs and I try to chart them on these plane, you can see that there are different distributed data points, which tells you a lot about how the business case would possibly evolve and what could be the impact. So anything that is coming right out here is like an intangible business value. That's very much understood, right? If you have something which is falling out here, you can definitely look into something that can actually generate value. If there is something which comes in here or here, they have their corresponding, let's say, cost reductions or resource reductions and all those kind of things. So these kind of picturizations, let's say if you have a tool and gives you such kind of insights in real time. Let's say you get up in the morning, you get this chart and you find out that, okay, entire power system management and like maintenance or the O&M activities are pulling the data points towards the right. You in the asset management portfolio yourself can actually look into that, how this can be brought on the left-hand side, right? Okay, having talked about the business case, let me tell you more about the construction and benefits. This slide more or less is self-descriptive, and I think majority of the people who are watching this, they already know it, but let me just speak 2 to 3 lines about it. So a use case to build a monitoring and the diagnostic center or a centralized monitoring system or an LDMS gives you a lot of benefits in terms of asset management to avoid catastrophic failures, spend capital which is optimized maintenance schedules, analyze and score the risk, compliance, productivity, and dynamic asset rating. Now, what do we mean by that? Definitely, it has its own definition, which is given on the screen that I'm showing. But then, having talked about, if you can see that it actually encompasses all the parameters which any of the O&M solutions possibly looking into. Now, think about, we already have a SCADA, right? Which definitely comes in with a black screen, which gives you all these kind of utilities. But moving, having in the world where actually we are moving every single day, we are speaking to a different sets of customers. You're always on the go. If you can have these kind of scenarios where asset health indexing is not, I think, if I'm mistaken, but they are not the part of any of these SCADA solutions which are conventional. If at all, these can be given in a portfolio where assets can be ranked, right? So let's say I say that in my power system, there are 4 transformers, out of which one is the best performing, and the fourth one is the worst performing. And what are the ways for making that worst performing the best performer? Those are the prescriptive solutions. If you can get it in a tabular chart and get a good heat map, it gives your business more amount of insights and taking more sets of beneficial actions, right? Okay, in terms of the same, now I'm starting to move about and talk in terms of having said about the higher value proposition and the organizational values and everything, where the asset management solution should probably lie. So if you can see that we have a preventive maintenance, we have a condition monitoring, and any business, I'm not going to spend much more time on this particular graph, but being its own self-explanatory as it is, you can see that the asset management solution should be constructed on the knee of this line, which gives you a good fixed between condition monitoring, preventive maintenance, the cost, and the solution which is somewhere in between the cost which is minimum to the cost which is optimally reliable. We at Oxygrid, we try to bring in solutions which happen to be in this knee area, so that we are not doing any excessive preventive maintenance. We are not doing something which is like, required, but we are not fulfilling it. But we are giving a solution which is, taking into consideration the prescriptive and solution which is giving you insights from the data which is being gathered. Okay. So basically, any utility or a discom would possibly want to know if the entire scenario stays in that knee region, right? Okay, now let's deep diver. Let's talk about, having talked about that knee value, what are the specific KPIs that possibly any discom, company would possibly want to look into? And what are the different sectors and what should be developed or is developing, right? So you have prescriptive analytics and remote control. Definitely it's a part of a SCADA, like remote control actually comes in with monitoring and control. But then on top of it, Oxygrid provides you solution, or Scope provides you solutions which are prescriptive. Prescriptive is something that I've already defined. But let's say if I have to just put it down in terms of its categories, the applications can range anywhere from generation, transmission, distribution, renewables, ancillary services, electric vehicles, demand response, O&M, resource optimization, telecom towers, etc. Assets, again, transformers, circuit breakers, relays, solar panels, wind turbines, inverters, batteries, diesel generators, etc. Now, the KPIs more or less are on the side of predictions of generation. Just a second. Yeah. So they are more on the side of prediction of generation, input and outputs. You want to predict the efficiencies, faults, failures, performance indices, uncertain factors impacting the generation, remaining useful life, asset health indexing, and all those kind of things. Again, when you do a prediction, as I said before, you also need to prescribe the ways of improvisation, right? Okay, having talked about it, we also look into something called as forecasting. We have written paper on the same where demand can be forecasted and they can be meaningful utility to the discoms where or the power providers where the certain amount of penalties are levied in terms of giving the right amount of load to the distribution side, right? So if you know all these things well before or proactively, you can take necessary actions in order to meet the demands, right? You can then compute the penalties. That you can maintain the demand supply ratios. You can control the overall power systems and prescribe optimal power flow. Again, there's something called as computerized maintenance management systems, right? So let's say you find out that there is an issue. What happens next? Is that issue unattended for like millions of days or whatever it is, and you wait until the power system dies? No, right? You log it into a ticketing system or a support system where that activity is assigned to a site engineer to be taken an action for. Okay. Where, let's say, you found out that the transformer has to, has a health index of around 3 on 5, and you need to perform a tan delta before actually the transformer would fail. Again, being Scope being our parent company, we happen to have different TNM tools which can be easily made available to the customer who's actually using them. If you guys are not using it, you can actually look into what are different products that we have, and then that could come to your rescue where you can actually use them on site, make sure that the operation and maintenance activity is done for that particular transformer. When you do that, you can actually list down. Okay, so what you can do is you assign a task of doing a tan delta to a certain site engineer, let's say ABC, and you tell them that you have to do a tan delta using some kit, and you tell them that this has to be resolved by 3 days. The moment the site engineer performs that activity, your O&M or your overall maintenance or the health index of the transformer goes high, which gets reflected into your overall performance of the power system. And then he can come back into the CMMS and close down the ticket just for the management to know that the entire issue has been resolved. With a feedback loop in the internal subsystem, you can say that the overall performance of the power system increases. This is again a very powerful tool when it comes to maintaining all these outages in a power system, which can be brought by a software, which is the Grid Analytics platform on OxaGrid, powered by Scope. Okay, this is pictorial definition of asset management. When talked about different kinds of classifications in this particular slide, I jotted down in terms of its application, the KPIs, and how it actually looks into a dashboard in the OxaGrid solution, which we call it as CAP. So what do we do? In asset management, let's say if there is a DISCOM customer who is serving to hydro, windmills, different kinds of solar power plants and different sets of utilities, okay, under a single canopy. You can have different portfolios under the same branch, and in that branch, you can have different sets of assets. So let's say you have a solar power plant, you will have a solar panel or a solar panel, and you'll have a combiner boxes, you'll have inverters, transformers, and all those kind of things. You just click on any of them and you can see what the asset health is, how much cost has been reduced, how much in terms of solving or resolving a particular issue on site, resources have been used or optimized, consumed, and how these resources can be optimized in terms of setting out right set of inspection routines, maintenance scheduling, and definitely the application. These all under a single tree can be seen by an asset management solution which we provide at Oxford. Sorry. Now, having talked about it, uh, you definitely would want to know that what are the different processes which actually go under the hood of asset management, right? So you can see in a nutshell, you have demand side management, the shareholding community expectations, regulatory obligations, demand and generation growth, which go under the network's vision and objective. So when I say network, you see it from a CXO portfolio, CXO level. When you see it from the CXO level and you start mapping out the different applications, you can also see the processes like planning the criteria, like a CMMS, the technical codings, generation forecast, management plans, and whatnot. Again, in the sense of investment strategies. So when I say that you have a certain set of processes which are going in place, you also want to see that if the technicals are good, how the commercials can be managed and forecasted, right? The expenditure forecast. I mean, it would definitely happen that you want to vouch for an oxidate solution, but then you would also want to see it from a perspective that how much amount of return of investment I have when I buy a certain tool, right? It's very viable. I mean, tomorrow if you buy like a Microsoft Office, right? You want to know that after implementing an Excel sheet into your entire process, whether it is actually optimizing or increasing or reducing the overall work efficiency, right? So you would like to see it from the expenditure terms of expenditure terms, and you would definitely try to map it from the perspective that after investing into a certain tool, how much amount of OPEX is being reduced, and that is the entire tool which would possibly come up when I said you need to resolve everything from the perspective of not only technical criterias but from the commercials or the financial criteria also. Okay, this happens to be the overall case of what asset management's blueprint looks like. But then in terms of application, what are the different use cases? One of the most important use cases that go into an asset management kind of a solution is the placement of IoT sensors. We have our feeder monitoring solution, which is the C that you're seeing on the left. And we have our own in-house built transformer monitoring solution, which we call it as STEM. They allow you to monitor the energies, define the rules and regulations, define the rules or protocols that allows you to increase the overall efficiency of the power system. So we provide these solutions in order to, I won't say extract, we measure this data because they're just IoT sensors. They get the data from site or from the certain analog or digital sensors, make it available to you on the cloud platform or remotely wherever you're trying to use it. And then you can actually look into the asset management portfolio to see what issue a certain component has in terms of optimizing them. Okay, having recorded these values, you also want to see that how the dashboard would possibly look like. Now, the dashboard has to be easily accessible. It should be accessible from the web. It should be accessible anywhere you are, right? So we have given a solution which is Web SCADA. So as we know that the conventional SCADA is an enterprise solution which sits out of on a computer, but then being hosted onto the cloud, your Web SCADA can be viewed anywhere. Again, one of the beauty of this particular solution is that you don't have to install any application or a third-party application into your system. So on your Android phone or on your iOS or Symbian or wherever you are actually trying to use this, all you need to have is a browser. You just put in your URL link, you have login credentials, and you're good to go. So we have hosted this entire idea into a web solution where you can have everything listed down as you're seeing on the screen with a map and see that where exactly the issue is occurring. They are custom made to meet user requirements, easy to use dashboards. We have our own UX UI team who actually creates these dashboards in order to make it more convenient for a user to actually use it. It should not be that it's so complicated that when you're trying to use it, it's kind of complicated to understand, because many a times the biggest roadblock that happens to the customer is that the overall solution is too complicated to be understood in its software level itself. So we have well-driven, easy-to-use UXs and the UIs, which enables drilling down to the raw data for detailed analysis very much possible. All right. These are some of the use cases which happen to be in the domain of fault predictions, asset health indexing, low carbon tech integration, where we tell you, given a certain area, what should be the displacement of a certain renewables into the picture, which would allow you to reduce the carbon footprint. Now, again, we have devised this solution not only from the perspective of giving a web SCADA or a SCADA so that it can be helpful to the utility, but then again, we are also looking at from the perspective of giving a sustainable outcome, right? So again, one of the key visions at Oxygrid is trying to bring in the sustainability by reducing the carbon footprint. Now, how do we do that? We have our own inset algorithms, which, when given a certain set of criteria or a certain set of parameters, allow you to understand that how much amount of PV or a storage or a wind solution can be integrated. Sorry. Then again, the limit violations, load transfer alternatives, benchmarking and comparisons, electricity theft, which happens to be one of the key areas where utility want to understand where the energy is actually going, right? Again, energy forecasting, renewables optimization. We have all these sets of risk assessment models like CNIMs. We have all the sets of neural network based solutions. We have all the sets of decision tree based solutions, which allow you to do all the kinds of regression and predictive outcomes which are data driven. And we have all the kinds of expertise which like the like the electrical, right? So our bread and butter is electrical engineering. So we have that basic understanding, and what we try to do is that we bring in that domain into the software so that the solutions are not just data driven but has a meaningful rationale when it comes to the dashboard. Okay, so this is the use case which we developed at a leading DISCOM in Maharashtra, which is a state in India, where we try to implement the entire thing that I just discussed, the idea of asset management, but then seeing it more from the perspective of an IoT-based energy distribution analytics system for giving it to a utility or a DISCOM in India, where they can monitor sets of power transformers, the auxiliary power supplies, feeders, and see how the consumers are consuming it. If there are any issues, if there are any sets of alerts that are happening, they kind of can be easily understood, and they can be resolved in real time in order to make sure that such kind of issue do not get aggravated in terms of an outage. Okay, that was about a single DISCOM, which was a use case which I wanted to put it in front of you. But then apart from that, we have also given these solutions to various DISCOMs in India. We have given it to various states like Maharashtra, Andhra Pradesh, Kerala, Arunachal Pradesh, Delhi, Odisha, Gujarat, Madhya Pradesh, and Nepal. Nepal does not happen to be an Indian country, but that is the place where we have also given IoT-based energy distribution analytics to a leading DISCOM. Okay. Apart from that, one of the key terminologies that we are implementing as a part of asset management is to incorporate all the kinds of testings that you do offline using these scope instruments. Uh, and that data kind of becomes a benchmark because these instruments are very well stagnated in the market. You have a reliability on these particular scores. So what we are doing is we're trying to bring in this data to the like not we are not trying it. We already have it in our Oxygrid solutions or the GAP software, where having done any testing on site, if it gets imported onto your asset management portfolio, what you can do is that taking this as a benchmark and having some historical data which is being given to you in real time basis, you're measuring it and you're trying to see that how these can be compared together. Because yeah, when you know, right, like if a circuit breaker fails, it's not just something which happened today. It's not an event which happens out of the blue, right? It is an aggravated event which comes down unless and until there is a spurious power system surge which could not be handled. And then that is something which we are trying to capture in the asset management portfolio, giving you results which are specific, and it gives you a good amount of understanding of what the asset is going to behave in the next coming 3 to 4 days. Okay, that is what I wanted to speak. These are some of the references that helped me build this entire presentation, and that has good amount of literature. That has good amount of know-how. If in case you want to look into, and you can actually have a sneak peek. It kind of helps you grow your knowledge. Okay, I am up for question and answer. Sanket, if you have any, kindly go ahead.
Doctor, currently there are no questions in the chat box. Just wanted to inform all of you that you can put on your mic and you can now ask your questions. Doctor, I have one question. Like when we are saying about this IoT things, the major concern is always have been the cybersecurity. So can you just put some light on it?
Yeah. So off lately, whatever we have been doing, and not only off lately, all the solutions that we are trying to give are hosted on cloud, which are developed on the EC2 services, which happen to be the Amazon cloud, right? Now, cybersecurity, as you rightly said, Sanket, is one of the key areas where any of the discoms, not only discoms, and like data is an asset, right? Data itself is an asset. Having breached into that domain would possibly be something that any of the discoms or any of the product owners would possibly not want it to happen, right? So what we're doing is there are very good layers that have been provided, and we have studied it our own, where solutions like Amazon Web Services, they provide you a good layer of encryption certificates or encryption layers that allows your data to be restricted to only your usage. So let's say that if there are any breaches, or there are any issues with the hacking system, because normally I get these questions a lot, that the data on the cloud is considered not to be that secure compared to the data which is sitting in a premise. But that is not the case, because believe me, anything that is on an intranet still has a higher potential to be hacked compared to something that is sitting on a standardized layer of cybersecurity, the way something like an EC2 or a Microsoft Azure possibly gives you. Because if you have a local service, which we try to provide it because we have done a little bit of study, but then my recommendation here is that whenever you go for a local service, there are additional set of layers which come in through our software package. But then if there are any evolving kind of cybersecurity layers which are possibly not built into it, then it's an added cost to the overall solution. But then with the EC2, the entire costing bucket goes into the OEM scope. So I think cybersecurity we try to take care of in different ways by, even if the entire computer is sitting in your local premise, by placing all the firewalls and all the necessary encryptions that are required for the data. But then when it comes to EC2, it gets already taken care of when it is hosted on the cloud. So we try to see it from these different perspectives and make sure that the data that has been hosted for any of the Discom customers, or any customers for that matter, they are completely safe and cyber secure.
Thanks. But then when we say that these are the IoT things, so can it communicate over all the protocols, the latest IoT protocols like MQTT and all?
Yeah. So, okay. So we have certain set of protocols that are ready. Some of them are already in the pipeline. What has happened is that some of the protocols which are ready are the ones which actually came into existence according to the customer requirements. As I said before, we develop the solution according to the market, right? So some of the protocols like MQTT or Modbus, they are kind of Modbus and so Modbus is actually there. MQTT is recently in the development, is going to be get completed very soon, and IEC 61850 and the related protocols, they are yet to be incorporated into the band.
Okay, but when it comes to power, other protocols are available, right? IEC.
Yeah, they are.
Okay, thank you. Anyone has any questions? I have just few questions to ask to him. So if anyone has any question, we'll wait for another minute or two. By the meantime, I have sent you the link in the chat box, so you can check the link for the feedback form. If you have any questions, please feel free.
By the way, I don't know. I mean, like Sanket, if there are no questions, possibly if there are few things which possibly you would want me to answer, like I don't know. I can speak more about like some of the utilities that possibly I might throw more light, because I kind of kept it a little bit short and sweet. Maybe some questions can arise from there also. I'll wait for 5 minutes. If there are no questions, then I try to see if
Meantime, can we have something which is related to the industries, where industries can also utilize this solutions for their betterment? If you can give some example of it, or just a case study also, that is also fine.
Okay, that makes sense. So what I'll do is, normally when we speak to the customers, these are the set of use cases that they come up to us asking that, okay, whether you have these kind of scenarios. And what I do is, when I was giving this particular slide, I kind of had given it on a very macro level. Maybe I can give you more particulars of it. Okay. So fault predictions, again, as I did mention before, having characterized a particular asset, you know that what it is going to behave like. But then, is there a possibility where you can tell and predict whether a fault is going to happen? Now, what we have in our algorithms bag is that we can actually look into the parameters of real-time parameters of a given asset, look into and predict when a particular fault is going to happen. These are all deep learning based or decision tree based solutions in the form of regression and classification, which allow you to predict a certain fault in real time and tell you that what and where the O&M activity can be programmed. Again, let me get back to you. I mean, let me take back to you the fact that, when I was mentioning CMMS, right? A CMMS is more of a system where the managers, like the oil managers specifically, they are not only meant to see it from a perspective of seeing a particular asset being malfunctioning or has a fault or an issue as such. He or she can also see it from a commercial viewpoint. Like, let's say, I'll give you an example. A fault fixation costs you like around $100, right? But against that, replacement is only like $80. It's always advisable to go ahead for a replacement, right? Because then you also have a remaining useful life which gets updated. But for a fixation, if you're using more amount of money and getting a solution which is then costing you more, but the remaining useful life is also something which is not optimized, and that is something that you have to take a call according to your experiences in the past. But with a CMMS, you can actually see this in front of you, where you have listed down what are the technical particulars, the efficiencies, the outputs, and what is the overall health index of a particular asset after the fixation, or what will be the health index after replacement. Obviously, it is going to be the maximum, right? So an O&M engineer can actually look into this and then think of assigning this particular activity for fixation or a replacement to a site engineer. So this kind of helps the overall resource management, allowing you to take decisions in real time. And fault predictions is not a certain area where you see it from the perspective of predicting a certain fault. It's an area to see that how your entire power grid is long lived, right? It should not be that your power system is just upgraded for a temporary basis, and then you are trying to look into whether it is functioning well as it was supposed to be. So fault predictions is something that many a times, and that is what I have experienced with when I talk to different customers, that they try to see that how this can be programmed better. Apart from that, again, when I was speaking about the fault predictions, I did mention about the asset health index, right? So just a second. So when I say, I'm so sorry. So when I say that asset health indexing more or less allows you to index your assets according to its rankings, wherein you can list down whether a particular assets like a transformer or circuit breaker is not having a certain health index, and then you start seeing it from a perspective of whether you want to replace it or you want to go for a fixation. We do this in real time, where we provide health index for every single asset in real time, telling you that whether it requires a repair or a replacement would be something which would be more advisable. Again, low carbon tech integration, as I was mentioning, that OxyGrid is not a solution which is only working into a SCADA, but seeing it from the perspective of reducing the energy losses, which also happens to be the use case of electricity theft. We have our deep learning algorithms in machine learning, which allow you to do or predict or forecast electricity theft. Okay, I won't call it as a forecast, I'll call it as a prediction in electricity theft, and which will also tell you that had it been a channelization of that particular energy towards a certain set of customers, like normally it so happens that the electrification does not reach the last mile consumers. So when I say last mile consumers, they are nothing but the rural sector consumers, like in the villages or the areas which are completely downtrodden. In those areas, if we want to make sure that the energy is reaching, you have to make sure that the energy as well as assets and the consumers are distributed. In that case, what you can do is that you can actually make sure that the more and more involvement of less CO2 generating or carbon generating resources or carbon generating sources are being taken into consideration. Having talked about a fossil fuel based system would possibly cost you a lot when it comes to carbon footprint. In that case, if I can tell you that, okay, you can install a solar power plant or a wind power plant so that it can actually form as an ancillary service and make sure that the demand response is being maintained, then that could be a value proposition. We have our own algorithms which run in real time. You just have to put in the particulars, and it allows you to displace the conventional power systems by something like a PV or a wind or a biomass or something. Again, if there are any limit violations, again, this are something which are set by discoms, like the voltages should not go beyond 33 kV, or we'd say that, okay, the power factor should not be below 0.8. These kind of violations can be seen in real time. And if there are any issues as such, the regulatory formulations can actually come into existence. This allows you to make sure that the entire power system is running into its corresponding optimized limits and making sure that there are no hindrances when the control actually seeps in from a discom or a utility. So it's like, allowing you to give a solution which is harmonic. You don't see it from the perspective of only one party. Like, it should not be that the consumers are demanding so high that the utilities are not able to provide, or vice versa, right? So utilities are generating so lower that the demand is not being met. Something of that form. So we try to give in all these kind of regulatory violations, which are obviously given to us by specifications from the discom and the utility, and we try to put it on our dashboards and try to see that when and where these can be implemented in order to optimize the overall demand response. Load transfer alternatives. Okay, so that there's a lot of power systems are infinite, as we already say by a rule of thumb, right? But it actually is not infinite. What happens if there is an overloading or if there's an imbalance? In such kind of scenarios, what you try to do is you want to switch the load towards a source which has high power. It should not happen that there are two generating sources. One is deficient, which is providing to a higher load, and one which is kindly sufficient and is providing to a load which is so underloaded. You need to have a balance between the two, because at the end it's a complex power system which is interconnected, right? When to switch the loads, when to make sure that the right sets of loads are being provided with the right set of sources. That is something we also provided as a use case in our web SCADA. Again, benchmarking and comparisons, where we try to tell you that who are the worst feeders, who are the worst transformers in a given bag, or who are the best performers, or who are the ones that require fixations. Electricity theft, as I said before, is one of the key criteria. It actually consumes a lot of amount of energy which is wasted, and this is also something that utility actually looks into when it comes to optimizing the amount of energy, maintaining the demand supply ratios in unison. You have energy forecasting, which as I said before, we have a demand forecasting or an energy forecasting that we do, where we try to tell to the consumers or the discoms that, not only discoms, to the consumers who want to see that given a certain demand in the past, through a data-driven approach, how much amount of load can be forecasted in the future. This lets them look into the future and program their loads. Utility definitely program their loads so that there are no deficit and they don't need to buy energy in the market. Okay. Then again, you have renewables optimization. So as I said, actually more or less correlates to our low carbon tech integration, where we are not only telling you that what could be displaced, but we are also trying to tell you that what is the optimization. Like, for instance, in solar, GCR is a constraint, right? The ground coverage. if you have a certain constraint, like, if you are working on a rooftop, or if you have a very less amount of area in an urban city, in that case, if you want to maximize your energy outputs so that the overall energy could be usable to certain set of consumers, we also provide that, and that happens to be one of the use cases in the Oxigrid branch. So these are some of the algorithms. Again, I think I have discussed few of the use cases which are very much relevant to our utility. I'll take a pause of 5 minutes. If there are any questions which will pop up, otherwise, if there are any more set of ideas which you want to discuss, I can, talk about it. Sanket, back to you.
Yeah, thank you, Doctor. I think he has given a wonderful presentation and letting us know that how this solution, asset management solution, can be used in a multiple way, not only to assess the health of a particular DUT, but also for the complete system. So this is how we can use it. And it is not restricted to renewables, not restricted to the your in-house server to get the data and everything. So he has spoken on a length over cybersecurity, then the latest technology which we are using it. So if you still have any questions, he's waiting for you. Or we'll wait for another 2-3 minutes. Otherwise, we'll conclude it. Doctor, I don't think there are any more questions. I think we can conclude here.
Okay, makes sense.
Okay. Yeah.
Yeah.
Thank you, everyone, for your time. Thank you, Doctor, for your good presentation.
Thank you.
See you some other time.
Yeah, sure. Thank you.
Thank you.